Thank you. Thank you very much for coming to my talk. I'm Volker Fritzsch. I work as an architect for Mercatus. That's a company in southern Germany. We are located in Ulm. That's between Stuttgart and Munich. You might not know it, maybe you might. Ulm is famous for the highest church in the world until Barcelona finishes his Sagrada Familia. That said, I want to know a little bit about you. I assume most of you have done Liferay Portlet development, so I'm not going to ask about that. But do you know or have you done any JEE development? Okay, that's a quarter, I'd say. Have you any experience with RESTful web services? Have you used RESTful web services? Have you designed a RESTful web service API? Okay. And OSGI, anyone played with Liferay 7 or Eclipse? Any OSGI containers? Okay, great. That said, let me tell you a little bit about my typical Liferay project. Whenever a customer comes to me and says, okay, Volker, we want to build a new web experience to better get in contact with our customers or to work with our suppliers. We want to have a B2B portlet, a B2E portal based on Liferay. I always get excited and I start to think about user experience and what you can do and how you can present information and how you could help them to deliver better products. And so much joy. And then reality hits me and I realize that most of the time you have to integrate a lot of different third-party systems. There's always some kind of special purpose database that you need to access for customer information or stuff like that. There might be an SAP system. Often there's a message bus in place, so you have to react on JMS messages. And sometimes you even have to connect to the old host system that's running in the basement on old spare parts. And while portlets are really great to interact with your users, a portal is not so great for third-party system integration. If you want to do more than UI integration, and by UI integration I mean writing a new front end for a given system by consuming its already exposed services. But if you have to aggregate information from different systems to build something new on top of that, that's hard, in my experience, to do from within a portlet. And our solution to that, which we evolved over several years in projects for different customers, is to bring Java Enterprise Edition back into the mix. Because most of the time, you already have an application server in place. Maybe your Liferay instance is already running on a JBoss or Glassfish, so you just can put an enterprise archive in there, or you have an application server somewhere else. And that changes our architecture a little bit. So we use Liferay as a presentation layer and concentrate our business logic and the integration and persistence layer into the JEE application. This by no means has to be like this all the time. We have business logic and persistence in Liferay as well. That depends on the portlet, and if it hits some kind of core business logic that we like to keep outside, or if it has some business logic that can easily live in a portlet because it's isolated. And to communicate between our JEE application and Liferay, we tend to use RESTful web services. Why? Because nowadays, nearly every application I can think of is able to call or consume HTTP. And when our application, and I think that's a given, becomes the new existing application for projects that will start to use our information, it will make it much easier for them to call our services and to consume them. A different view on this architecture is this one here. So we've got our Liferay Portal, and we've got different portlets deployed in that. And some of them, or all, are consuming our REST API from our JEE application that we built using DrugsRS. And we've got our typical stateless session beans in there and some JPA entities. So no magic, that's more or less basic Java enterprise stuff. Our architecture aside, let's talk a little bit about RESTful web services. First of all, a disclaimer. Roy Fielding, who, if not invented, at least coined the term REST and RESTful web services in his dissertation, would probably not approve of what I'm going to tell you next, and so I hope he's not in the room, because I'm going to violate his understanding of REST services a little bit. I'm going to ignore some parts. In his point of view, REST service should be self-describing. I'm going to ignore that. His view of REST service says it should be independent of the kind of transportation. We are just talking about HTTP, and I'm not going to talk about the representation of resources, JSON or XML at all. I'm just concentrating on the 2 points I think are most important to build a good REST API, and that is, first of all, learn to build good URLs, resource identifiers, and second, learn when to use which HTTP method to access, or to give that URL some meaning. Regarding URLs, I've got 2 examples here, and typically an URL points to a collection of elements or an element directly. In our example, the first URL points to a collection of talks that belong to a specific DEVCON object, the DEVCON 2014 object, and the second URL points to the talk with the ID number 7. We don't make any assumptions if the ID number 7 is globally unique or not. We do know it's obviously unique within the DEVCON 2014 object. Now, if we want to access those objects, we're going to use HTTP GET. HTTP GET is, in my experience, the easiest to understand, but it's quite hard to get it right when designing APIs, and that's because of some conflict between back-end designer and UI designer. But I'm going into that in a moment. First, let's have a look at the first URL. This returns us all the IDs of the elements in the talks collection. So if I want to know which talks are part of my 2014 resource, I'm just going to fire a GET request to that URL, and I get a list of IDs. And then I can use that IDs to access the single talk object. Give that to your UI developer, and it will take minutes to hours, and he stands in front of you and says, okay, Volker, we've got a problem. Now I got to make n+1 REST calls, because I need 1 REST call to get a list of talks, and then n talks for each resource. And that's way too many. So that's mostly the time when you sit down and think about which information will be needed immediately and which we can postpone later on. So you don't only, most of the time you not only return the IDs, but a list of pairs of IDs and names, for example. So you can display all the names just immediately. But be aware, when it comes to REST, you should also have caching in mind, and everything that you put into that list, and if that changes just in 1 object, you have to invalidate your complete resource. It can't be cached anymore. And that's the reason why I'm always starting with only returning IDs and then adding more information later on, and to keep that as small as possible. Post is the next HTTP method in our toolkit, and post is used to create new elements. So if I want to create a new talk element, I take all the information I've assembled on the client side, put that in my request body, and fire it up to the backend. The ID, that's generated by the server. So we are creating an unnamed entity. Hopefully the server returns that created entity in its response, because otherwise we don't know where to find it. And that's the main reason to use post. And the other useful, or where post is appropriate, is if you want to call some exposed method, for example. Let's say you do not only want to get and manipulate resources, but you have some methods that you want to call. For example, I want to have to be able to approve a call. Then that's something that's all should be called within post request too. And controllers are easily identifiable because they end in a verb, while resources are more or less a noun. Then we've got HTTP put. While post is for creating, put is more or less an update. With the exception if the resource you're going to update does not exist yet, then it's a create. And it's a named create because I'm saying, please create talk number 7. And not just create a talk, assign it an ID, and return that to me. I'm specifically saying talk number 7. And the final method in our toolkit is HTTP delete. I think we don't need to talk that much about it. It just removes an element from the collection. From a consumer point of view, it's not relevant if it really has been deleted or if it's not longer part of that collection, because I can't make this distinction on the client side. So it's just removal from a collection. And finally, when you start implementing your REST API, please use caching headers. At first, you most probably won't need them because you have not that many consumers. But if your application is really used sometime, and to be honest, we all hope that the stuff we build is used, then this will come in handy, because your application might be hit by a lot of traffic, and those caching headers helps us to apply what we've learned in the internet over the last decades, to use caching proxies, to put CDNs in place and stuff like that. And if I use that stuff early on, I can leverage that immediately. And it's not hard. For example, in eTag, just put the hash code of your object in there. Last modified, maybe you already have a last modified date on your entity. Just put that stuff in there, and then if you really when a new get call comes in, just compare that and return a 3 or 4, which means not modified, and then the client can handle that. Okay. That's it to REST APIs. Now let's talk about how to call your backend API that you've got in place. So how to do that from within a portal. And I'm going to talk about 3 approaches. The most naive one, just putting that code into your portal class directly, I'm going to ignore that. The first approach that we started with is what I call the client jar approach. You put all the communication code, that means your client REST API and DTO object, so the objects that you put into your API and that you expect as a return value, into a client jar, and you give that to your Portlet developers. And they can immediately start to communicate with your server. You can create that client jar on the enterprise side, so if you have some guys that are dedicated doing JEE work, they are easily able to do that. And they have, with that, additionally, some possibility to test their service, to do some integration testing if you want to. And you can provide a nice API within that, but it comes with a downside. due to how class loading in servlet containers works, you can't share any information between different wars. And that means if you got that client jar in 2 different portlet projects, you might have duplicate requests. So for example, if I've got 2 portlets, my first portlet and my second portlet, and both are in different WAR files, and both have the client jar as a dependency, and unfortunately both need to call the same method, and we've put both on the same portlet page, I've got 2 requests with the same request and the same response, and that's absolutely unnecessary, but there's no way I can do anything about it, because the class loader separates that. And that led to our second approach to solve that problem, because Liferay has something in place that's called the service builder. And the service builder is actually quite well suited for that kind of problem. I've got more or less a singleton within my Liferay portal that provides a service and that I can use from every other portlet out there. And so if we put all that communication code in there, then we have a shared API between all the portlets, and that means we can do some really cool and sophisticated caching, because Liferay already supports us and brings with it EA cache and single VM pool or multi-VM pool. So you already have clustering in place and stuff like that. So you put your the responses you retrieved from the server into the cache, and next time someone requests the same resource, you just look, okay, do I need to get it overall? Has it expired yet? Otherwise, I'm sending the e-tag with it. If I get a 304, then I just can return what I've cached. So I can really reduce the number of requests and the amount of traffic that is needed. But this comes with a downside too, because Service Builder is not 100% suited for that task. And that is due to, in an ideal world, my Service Builder implementation and my API portlet services, which are dependent on my DTOs, would be all in one class path, and my portlet would call the portlet services, the interfaces, which would call the implementation, that means the API portlet, and that would do the REST call. But in reality, we have more or less different WAR files. So I've got my first portlet that has the portlet services in its class path as well as the DTOs. And I've got my implementation that's part of a different WAR file. And between 2 and 3, it's going to break because my DTOs are from a different class loader. And that means I get class cast exception that many of you might have already been seen, most probably with a different class, but it's always something like my object cannot be cast to my object. And then you sit in front of your stack trace and think, oh, what's going on here? And that's exactly that. And that's because we don't use the persistence part of Service Builder. If you let Service Builder generate your entities, then that's no problem, because then he can generate specific serialization and deserialization code to handle that. But we want to use objects that are provided from our backend system and that are not stored within the Liferay database. And we already have them, and those are complex objects. That's not a string or an integer. And I am not willing to put them in the shared library of Tomcat or something like that. I want them to be part of the portlets, to isolate that. And the way CLP serializer is generated by Service Builder, it's not suited to break that class loader barrier for objects that are not generated by itself. But fortunately, there are some solutions. One solution would be, and that's the solution we did, just to hack the CLP serializer, let it generate from the Service Builder, and then just put some code in there. There's a Liferay issue that details how to do that from Juha Palomäki. Easy. If someone regenerates a service, that changes are lost, but we've got version control systems in place, so that's no problem. Just revert it, works fine. And to be honest, that overriding by regeneration happens once at most. That failure, nobody does that twice. The other way would be to change the free marker template that the service builder uses to generate the CLP serializer. Would be possible, we didn't do that. And the most elegant solution, in my thinking, would be to leverage Spring AOP to put an around device that does the serialization and deserialization. But we didn't do that as well because we've got the OSGI service approach on the horizon. With Liferay 7, all that won't be necessary anymore. Just put your communication code in an OSGI bundle, deploy that into Liferay 7, declare that bundle as a dependency on your portlet bundles, that's it. The OSGI container will resolve all that dependency mess and you're fine. I'm really looking forward to it. We haven't tried it yet. I didn't have time to try that with the milestones, but I'm pretty sure it will work and it has to stand the test of time, that's for sure, but yeah. Okay. Thank you very much for listening to me. Do you have any questions?
With the second approach, is there a way to get it to work with Maven? In your knowledge, because it's used by Ant to create a jar file with the service classes in, but to my knowledge, we never got it to work with a Maven plugin.
We are actually building all portlets and all service builder portlets with Maven. So this does work.
It does work.
Yeah.
All right.
I can show you an example POM file later on.
Oh, thank you.
Yeah.
Any other questions?
Excuse me, I didn't got it. Why do you use Liferay in your project?
Sorry, I didn't get that.
Why do you use Liferay?
Liferay?
Yes.
Yeah, because it's great to present information to your users. Okay, I could say we don't use it at all and let's just build a web application. We did that, 2000 each. We had a framework that was called Wings, developed in-house with another company that more or less took Swing and put it into the web. So we did component, HTML generation, all that stuff. We don't use it today anymore because I don't want to do user management, web content management, documentation, document management each time for each project. Liferay, it supports all that out of the box. It has services. There's everything in place. Only some functionality I sometimes need is missing. Reacting to JMS messages from the outside is probably somehow possible within Liferay, but it's much easier in an application server because I've got my message-driven beans and that's it. And that's the reason for me to use, to bring an Java Enterprise container into the mix. But for everything web-related, I think currently Liferay is the best solution.
How will you use this solution in a single-page application?
Would be possible. You could call that the REST services in your backend from within your application.
So the first solution.
Sorry?
The first solution that you mentioned.
I didn't get that.
So you'll use the first solution that you just mentioned?
No, that solution as well. you are using, or?
No. I use add that first. You'll not call the REST services directly from your page, and you'll skip that solution. But in a single page application, you'll call directly those REST services.
If, for example, I would take AngularJS and put it into Liferay and have a portal application that more or less bootstraps the AngularJS entry app code into my browser client, and then he uses the REST services directly. I don't need a service builder portlet, a client, I don't need anything. I don't need any of that. Then I could directly call my REST API. But then there would be no difference. Yeah, then my application would be like every other third system that I'm going to access. But that would be a nice solution, yeah.
Thank you very much. I think we have to wrap up with the question. If you have any open questions, please feel free to find Mr. Fritzsch all day. Thank you very much, Mr. Fritzsch.
Thank you.